Today, we will be going over how to create and use an ice table to analyze an acid-base equilibrium reaction. We will be creating an ice table for when 0.0784 moles per liter of a weak base called aniline reacts with water. We'll be looking to find the concentration of all solute species once the reaction is at its equilibrium point. Recall how to write the ionization reaction for this specific reaction. Aniline will react with water to produce aniline's conjugate acid and hydroxide. For an ice table, we will only use aqueous species. Recall that aniline's conjugate acid, and hydroxide are all aqueous. This means we will not include water in our ice table because it is in its liquid phase. These tables are called ice tables because we use the abbreviations ICE, where I stands for initial, this is where we put all initial concentrations, C, which stands for change, this shows how much each concentration will change by in order to reach equilibrium, and E, which stands for equilibrium. This row will have all final concentrations for each species. We are told that aniline begins with a concentration of 0.0784 moles per liter. We know that there are no products initially, so aniline's conjugate acid will begin with a concentration of 0, and we are told that the initial concentration of both hydroxide and hydronium are negligible and therefore will also be written as 0 moles per liter. Our change is dependent on the stoichiometry of our reaction. In this case, each solute species has a stoichiometry of 1, and therefore the change will be the same magnitude for all species. All reactants, which is in this case aniline, go down in concentration and therefore will have a negative change. All products, in this case aniline's conjugate acid and hydroxide, will have a positive change because they are all increasing. Reactants are used up to produce products. Our change will be represented by a variable x. So aniline will be minus x since it is going down, and aniline's conjugate acid as well as hydroxide will both be plus x since they are going up. Our equilibrium row will be the initial concentrations plus or minus the change. So aniline will be 0.0784 minus x. Aniline's conjugate acid will be 0 plus x, so just x, and hydroxide will be 0 plus x as well, so just x. We will now solve for our change, represented by our variable x. First, we must write the reaction's equilibrium expression. This will be Kb, since we're working with a base, is equal to the concentration of products divided by our concentration of reactants, which is concentration of aniline's conjugate acid multiplied by our concentration of hydroxide divided by our concentration of aniline. We know that the Kb for this specific reaction is 4.0 times 10 to the negative 10. This value is obtained from a table in TRU's LibreText. Now, for this part, to plug in, we will plug in our values from our equilibrium row. This will have x's in it, so it will look like this. X times x, since both of these are x's, divided by 0.0784 minus x. Here, however, we can make an important assumption. So since we're working with a very small Kb, which is less than 1, we can assume that the change is much, much smaller than 0.0784, so our calculation will look more like this, without 0.0784 minus x. It'll just be 4.0 times 10 to the negative 10 is equal to x squared, since x times x is x squared, divided by just 0.0784. Now we will solve for x algebraically, isolating x, so we will have this multiplied out on both sides, which will give us 4.0 times 10 to the negative 10 times 0.0784 equals x squared. Now, those multiplied together equals 3.14 times 10 to the negative 11. And to isolate x and get rid of this squared, we take the square root of both sides, and that gives us x equals 5.6 times 10 to the negative 6, meaning our change is 5.60 times 10 to the negative 6 moles per liter. We will now replace all x's with our solved change value of 5.60 times 10 to the negative 6. So our equilibrium for aniline will be our initial concentration minus 5.60 times 10 to the negative 6. You can calculate this out, but our change is negligible, so we will always get 0.0784 back. And since our equilibrium for both anilines, conjugate acid, as well as hydroxide are just our change, just x, both of these will just be 5.60 times 10 to the negative 6 moles per liter.